last wee bit of standard deviation, then the most common exam question in standard deviation is to ask you to compare two standard deviations and make a comment about them. Okay, so we need to really know what the standard deviation means. Okay, when we're talking about the mean, it's talking about the average. When you're talking about standard deviation, you're talking about the measure of spread, so you're talking about the consistency of your data. So the smaller your standard deviation is, the more consistent your data is, or the less spread out it is. The larger the standard deviation is, the less consistent your information is, or the more spread out it is. Okay? So if we have a look at this example then, example number 4. A runner has recorded her times in seconds for 6 different laps of the running track. To calculate the mean and the standard deviation. So we'll start with the mean. So for the mean, we add them all up. So 53, add 57, add 58, add 60, add 55, add 56 is 339, and we need to divide by 1, 2, 3, 6. Which is 56.5. Standard deviation, you can choose whatever formula for standard deviation that you wish. I'm going to go with the second one, and I do tend to use the second one far more often than the first one. Okay, so I'm going to work out my sum of x, which I've already done in my mean, it's 339. I'm going to work out my sum of x squared, so 53 squared plus 57 squared plus 58 squared plus 60 squared plus 55 squared plus, and I think that's a 56 hiding it, yeah, 56 squared. And that is 19,183. 19,183. Standard deviation then. Standard deviation is the square root of the sum of x squared minus sum of x all squared divided by n all over n minus 1. Put some numbers into this. It's the square root, sum of x squared is 19,183 minus sum of x is 339. 339 squared divided by n, which is 6. Just in my square root sign a wee bit. Divided by 6 minus 1. Let's get the calculator working. So 19183. So we get 19183 minus 339 squared over 6, which is 29.5. So the square root of 29.5 divided by 5. If you've used the other formula, you should be at the exact same point by now. So that's the square root of 29.5 divided by 5, which is 2.4. Okay, nothing new there. That should have been all the same as just calculating standard deviation we've done in the last couple of videos. The new part's on the next page. We need to know our two answers here. So our mean is 56.5, our standard deviation is 2.4. I'm just going to write those down. So mean, oh, I've forgotten it already. Our mean is 56.5. Standard deviation is 2.4. I think it'd be easy to remember two numbers. Okay, right, she changes her training routine, hoping to improve her consistency. If she's improving her consistency, that's talking about standard deviation. So if we're going to improve consistency, hard for me to say, we want the standard deviation to be lower. After this change, she records the time, so her mean is 55 seconds, her standard deviation is 3.2 seconds. Has the new training routine improved her consistency? But if we have a look at the mean's gone from 56.5 to 55, so she has reduced her time for her laps, her average time for the laps. But that doesn't tell us anything about consistency. For consistency, we want to look at standard deviation. Standard deviation has gone from 2.4 to 3.2, so she has not improved her consistency. So we say she has not improved her consistency as her standard deviation has increased. Okay, so on average, her time has got lower, so she has got faster, but it's not asking us about whether or not she's got better or faster. It's asking us just about the consistency, because that's what she was hoping to improve, and that she hasn't improved. Standard deviation's got bigger, so she's become less consistent. And that's the end of standard deviation.